So now what we're going to want to do is to actually return some data, because the user is going to want to come into this data set and actually get data out of here. Now, normally what you'd do, or you'd have your existing application that you're going to serve up this data from. So you would probably have a set of business objects that you would expose through that in any case. So normally, what I'd expect this to do would be a simple mapping between your business object and the contract business object. So the contract business object would be the specific implementation here. In this particular example, it's the G3M contract. So if you went and looked at the schema for this, you'd see it defines things like contact feed entries, trading account feed entries, commodity feed entries. There's a whole range of them. In this particular example, we're just going to implement the trading account feed entry. A trading account is a generic term to mean both customers and suppliers. So in our fictitious application here, we've got a set of business objects that we're going to use to expose here. So we've got a customer object, and we're going to expose it as the trading account feed. So just so we've got some data in here, I'm just going to very quickly create those business objects. So this is nothing to do with actually creating a provider. This is I'm just doing this so we've got some data that we can expose here. So I'm just going to quickly create them. I'll explain them in just a second after I've created them. So we've got a customer class, which is a single instance, and a customers, which is plural. So what we'll do here now as well is all I've done here is to create a static collection, a dictionary of our customer object. So as I said, this wouldn't normally be in your adapter. You would be actually going back to your business objects for this in your main application. This is purely and simply so I've got some data to expose. So all we've got here is a collection of customers, a method to create some customers here with some random data. So I'm literally just creating 100 customers here with a random identifier based on a GUID, and a pattern for the name, and some random balances. So nothing too onerous there. So now that I've got some data that I'm going to expose, and as I say, you would already have this in your own application, first thing I'm going to do is to create another new class, and this is the contract class. So I'm going to create, as I said before, we're going to expose trading accounts. So I'm going to expose something called a trading account feed entry. So this is a single instance of a trading account. This needs to be publicly visible because it's the Sage Integration Framework will serialize this for us, so it needs to be able to understand the type and access that type externally. And we're also going to inherit it from a class called feed entry. The feed entry is in the Sage Common Syndication namespace. The feed entry, again, it's just another helper class, and it offers us a lot of core functionality and enables the SIF to handle its serialization. Just by inheriting from feed entry, it gives the SIF enough information to understand the class, what sort of thing it is, even though we will extend it here with additional information. So in here we're going to expose a collection of trading accounts, and what we're going to want to do is tell the SIF a little bit about what the consumer application is allowed to do with trading accounts. And the way we can do that is by decorating it with an attribute, and that attribute is SME resource, and that's in the Sage Common Metadata namespace. Essentially, it is about metadata. What we'll do using this is to tell a consumer application whether you're allowed to retrieve trading accounts, whether you're allowed to create them, update them, delete them. All sorts of other useful information we can pass back as metadata to the consuming application. And I'll show you a little bit later on when we generate the schema, one of the really useful things that you'll get out of here just by adding a little bit of information as an attribute. So in here we'll just use some named attributes. So we have can get, which means are we allowed to retrieve the data. So that's going to be true. We are going to support that. We'll say can post, which is can whether you can create a new customer record or new trading account record. I'm going to say false for that. We're not going to allow creations. So can put, which is to update an existing trading account. We are going to support that in this example. And can delete, just to round it all off. We're not going to support deletions in here. You can obviously go off and support these things if you like, but for demo purposes we're not going to implement them, so we should tell consuming applications that we're not. The other thing that I'm going to pass in and say here is it has UUID equals true as well. UUID, universally unique identifier, it's something within the Sage integration framework that allows us to uniquely identify a particular resource. By specifying that it has a UUID, then the SIF will know that it can use that to uniquely identify it, rather than relying on any other implementation that you may need to provide yourselves. We'll see the use of that a little bit later on. So we've told the SIF now what can be done with this resource. So let's actually expose some real data here. So what I'm going to do here is I'm going to have a local cached copy of our customer. So we've got our customer business object. So for simplicity, I'm just going to hang on to a copy of that here, customer, and we'll just call it customer. So all I'm going to do here is provide a thin wrapper around a customer. You might have much more complex processing rules that you would use, or you might be consolidating multiple resource kinds into one. But for the demo purposes, it's just a simple wrapper around the customer. We'll also create a default constructor for the trading account, which takes a customer, and we'll set all customer equal to the customer passed in. And finally we'll have a default constructor which simply news up that customer, so we'll just do equals new customer. Okay, so that just guarantees that we're going to have a customer to wrap this up. So what we need to do is expose properties in the manner that adheres to the schema. Now the schema that we're adhering to is the GCRM schema, as I've noted earlier. You can go off and look at that schema. It's just an XSD file that you can download on GitHub. So that'll define a number of properties such as the name, the balance, the sales invoices and orders, and all sorts of really rich information, and we're just going to expose a handful of those properties. So I'm just going to very quickly bring in some pre-canned code. Let's make the screen a little bit bigger here and go down and show you what we're looking at. So we've got a property in the schema called reference. That reference is the internal unique reference. This is different from the UUID that I mentioned earlier on. This is the unique reference as from your application. So this is just how you would refer to it internally. So if you were to look at the demo data in Sage Accounts 50, for example, you would find that this would be A1D001, which refers to A1 Design Services, for example. So here, what we're going to do with it, when we get the reference, we're just going to return the reference straight from the customer. Now, these do happen to have the same names, just for simplicity's sake here. Typically, you might not have that. You might be actually called ID in your own object model. So it would just be a simple case there of customer.id. When we set the reference, we set it to the value that we're passing in, same idea. But we also call this method, and this set property changed method is defined in the feed entry base class. And what it allows us to do is to inform the SIF of just the properties that are changed, which allows us to get deltas, or just the changes. This is quite important when you're doing a lot of changes. So you might actually do a batch update operation, for example, which was to say set the balance or the open date or some other key bit of information, or set the status of an account. And because we're dealing with XML when we look at SData, that sort of you could end up with a lot of redundant information in there. So if we'd only changed, for example, the credit limit, then there's no need to send the website and the balance and the date the account was created. That's redundant, so we can cut down on a lot of that. So by calling this set property changed, passing in the name of the property and a boolean values to say whether or not it has or hasn't changed, we're giving the SIF enough information to generate that delta information. The only other thing that we've done is we've decorated with these SME string property attribute, or string double or decimal, whatever the actual type is. Again, this is metadata which the SIF will make use of, and again we'll see it later on when we come to generate the schema, where the real use of this comes from. But all we give that here is a label, so that can be a label which is globalized, if you like. So you could here have it's referred to as reference here in English, but you could have any other term in French, German, whatever you like. The name is the schema name, and that is case sensitive. And then namespace is the schema namespace that it belongs to. So in here it's the CRM ERP, which is the original name for the GCRM contract. So that's our individual instance of a customer, of a trading account, by wrapping up a customer. So with the properties implemented here, the other thing that we need to do is to provide a further bit of metadata information to the SIF, and I'll just bring in another set of pre-canned code, and I'll just quickly import the namespaces here. And so what these are, as I say, essentially help us for the Sage integration framework. We'll see the real benefit of it later on when we come to do the schema requests. But what it's really doing is letting the SIF have a mechanism of discovering the XML type, the XML qualified name, and the XML namespaces which are used by this particular type. So now that we've got that in place, we can move on to the trading account feed, which is the collection of trading accounts. So I'm going to add a new class called trading account feed. So this is going to be the collection of those those trading accounts. Now here I'm just going to again bring in some pre-canned code. You can see there's nothing too clever about this. We've just got our trading account feed, which inherits from the generic type of feed of type trading account feed entry, i.e. the class that we created just before. In its constructor, I'm just going to go off and get every single customer and add them into its entries collection. So this is the static customer list that I created before, just so I had some data to expose. So again, you would be getting this normally from your object model rather than hard coding it like this. You would also want to analyze the incoming request to see whether or not it's been filtered in any way. We're not going to implement filtering here, but if you want further detail on filtering, if you go to the sdata.sage.com website, you can find full information on there about how filtering is achieved and the filtering language which is used. So here, as I say, we're just going to iterate all of those 100 randomly created customers that were dealt with before, and add them to the entries collection. So that's enough to be able to retrieve it out of our object model and expose data in the way that they adheres to the contract, in this case the GCRM contract. So now that we've got the trading account feed, as in the collection of trading account feed entries implemented, that's exposing our data now. So we've taken our own object model and we've wrapped it up in some contract classes, these trading account feed and feed entry to expose our data. So the final piece of the jigsaw is to accept an incoming request from the SIF to say that data is wanted and to return that information. So for that, I'm going to create a new class, and I'm just going to call this class request handler. The actual class name doesn't make any difference, but it does need to be public because the SIF will be calling into methods in here. So what we're going to do in here is respond to the trading accounts request first of all. So again, I'm going to just have a hard-coded constant here for the path. So I'm just going to call it trading accounts path. And the path is trading accounts. So what that's there for is to say that we're going to understand the path called trading accounts, and by path I mean part of the URL, and I'll show you in just a second when we make the request where that comes into play. So the next thing I'm going to do is I'm going to create a new public method called getRequest. Again, the actual method name doesn't make any difference, but this is going to be the request handler for the trading accounts path. And what will happen is when the Sage integration framework calls into this, it will pass us something which implements the interface called iRequest. So that's capital R, and that's in the namespace Sage integration messaging model. We'll just call that request. Now, to tell the SIF that this request in particular, this method, is going to handle the trading accounts request, we're going to decorate it with another attribute, and that will be the getRequest target. And we're going to pass into that the trading accounts path variable that we created before. So what that's saying is that this particular method, whenever the SIF gets a request for the demo adapter, which ends with which has a resource kind of trading account, it's going to direct it to this method here in this particular class. You can use wildcards if you like. Instead, here for simplicity, we're just accepting one particular path. You could just put an asterisk in there if you wanted to handle everything, and then work it all out internally based on the URI if you prefer. So all I've got to do with this is, in that request method, request object that was passed into us, we need to set the response on that. So if I look at the request, there is a response object, and you see there's a lot of information in here that you can get out of it. You'll see for example, the URI, the user, so you can check for credentials and things like that. But here we just need to set the response, and in the response, depending on the request type that's being made, you'll either want to set the feed or the feed entry. So we're either requesting a number of resource kinds or a single resource kind. Here we're just asking for everything, so it's going to be the feed, as in the collection. And all I'm going to do is set that equal to a new instance of the trading account feed. So that's the trading account feed that we created earlier on, and within that trading account feed, in its constructor, it was going to just go off and add all of the 100 randomly generated customers into the list to be used. So that's enough now to tell the SIF that we can respond to the trading account. It was enough to get the data out of our object model and to wrap that up as a trading account or a collection of trading accounts. So I'll just build that now. So there we go, build succeeded. So again, what we like to see. So we can now go back over to our web browser, and I'm just going to copy the shortcut here. So this is the URL that we respond to. So there's a very particular format to the SData URL. So it's always the protocol, HTTP or HTTPS, the machine name, the port that we're running on, SData. Then the next bit is your application specific path. So we called it demo app. If you remember way back at the start when we created that constant for demo app, it's then slash the contract name, and again that's the thing which we hard coded as G3M. Then the slash the dataset identifier, and you see that's just got a little dash in there, which is the default dataset identifier. Typically you'd have something more meaningful in there. And then after the next slash, it's the resource kind, and that's where it's in this particular example, it's the trading account. So we're going to ask for trading accounts here on this adapter. So what that'll do is the SIF will go off and load our adapter that we've created. It'll call into our get request method there based on the fact that we've asked for trading accounts, and it will return to us a feed containing our trading accounts. So you can see here, here's our 100 randomly generated customers, semi-randomly generated customers. If I look at the source for this particular page, you can see here's all of the XML. So it's just an XML feed implementing the Atom format. So here we can see the HTML representation, we can see the actual payload in here. So this is what you would be dealing with programmatically as a consumer. So this is the whole big long list. So that's our data exposed to consuming applications. The next thing that we're going to do is to allow a user to actually to request the schema. And the schema is the thing I've mentioned a number of times before. This is how a calling application can determine what our particular SData provider implements in terms of a contract.